Welcome to this video lecture on the subject electronic circuits. So in this subject we are going to discuss about single tuned amplifiers. So what is the need for single tuned amplifiers? So in electronic circuits, particularly for frequency selective applications, for example radio and television receivers, we need to tune the or select the frequency of the particular channel. So we need the single tuned amplifiers for selecting a particular frequency and amplify the signal. So this is the need for single tuned amplifiers. And what is mean by single tuned amplifier? So let's see the definition. An amplifier with a single tuner section. So as shown in this diagram, we have a parallel tuned circuit. It is also known as a resonant circuit. So this circuit is used at the transistor amplifier circuit. So this is known as the single tuned amplifier circuit. So let's see the circuit diagram for single tuned amplifier. So in this diagram we can see the BJT transistor in common emitter configuration, where emitter is common to both input and output, and input signal is applied to the base of the transistor and output signal is taken from the collector of the transistor, and tuned circuit is connected at the collector of the transistor. So remaining are biasing circuit. So this is the circuit diagram for single tuned amplifier. So high frequency signal is to be amplified in this amplifier. So it is given at the base of the transistor. So tuned circuit offers the high impedance. So this tuned circuit selects only the desired frequency. So all the other frequencies are cancelled. So let's see the working of single tuned amplifier. So here it depends on the resonant frequency of the tuned circuit. So we have inductance and capacitance. So from this resonant circuit, high impedance offered for the tuned frequency. Other frequencies are rejected. So the principle of single tuned amplifier is based on the resonance phenomenon. So in which resonant frequency is depends on the inductance and capacitance values. So resonates at the frequency of 1 divided by 2 pi root of LC. So let's see the comparison of single tuned amplifier with double tuned and staggered tuned amplifiers. So in this single tuned amplifiers uses only one LC circuit and a narrow bandwidth, simple design, and in case of double tuned amplifiers we use two coupled circuits. In staggered tune we use multiple circuits, and also it consists of a simple design in single tuned amplifiers, and for double tuned it is improved selectivity, and also in case of staggered tuned it is complex design. So these are the comparison of single tuned with other tuned circuits. So why single tuned is preferred in means of simplicity and effectiveness in RF amplification. So it provides the balance between performance and design complexity. And frequency response. So we can see the graph between impedance and frequency, or we can see it is gain versus frequency. So at the resonant frequency the gain is maximum, so which is having a high quality factor at this point. So this provides a high selectivity in the tuned circuit. Next is the bandwidth of the tuned amplifier. So bandwidth is the range of frequencies. So here we take resonant frequency means, with gain is within 3 dB of the maximum gain at the resonant frequency. So we can write the bandwidth as Fr divided by QL, where Fr is the resonant frequency and Q is the quality factor. So this ratio gives the bandwidth of the single tuned amplifier. So bandwidth is inversely proportional to the quality factor. So here the single tuned amplifier, the bandwidth is narrow. So quality factor is high, means it provides better selectivity in the tuned circuit. And what are the advantages of the single tuned amplifiers? It is a simple circuit because it consists of only one tuner section at the collector circuit. So this is the simple tuner circuit. and also high gain at resonant frequency. So we have already seen the frequency response. It provides high gain at the resonant frequency, and also good selectivity. And let's come see the disadvantages of the tuned circuit. It provides a narrow bandwidth because it is having a high quality factor at particular frequency, so it is providing a narrow bandwidth, and it is only used for narrow bandwidth application, and gain is sensitive to component variation, so it can be difficult to tune the circuit accurately. So these are the various applications like radio receivers, transmitters, and oscillators in various electronic circuits, and filters and instrumentation amplifiers. So let's conclude the single tune amplifiers, where we use this circuit for selectively amplify the signals at RF circuits. These are the assessment questions. So in single tuned amplifier, quality factor primarily affects the bandwidth of selectivity of amplifier. And what is the primary function of tuned LC circuit and single tuned amplifier? To achieve a maximum gain at a specific resonant frequency. So thank you for listening this lecture on single tuned amplifiers. Thank you.